Ever wondered why the universe is acting like an overinflated balloon that's about to pop right in our faces? Or why scientists are low-key panicking because our standard model of reality might just be a massive glitch in the matrix? And more importantly, have you heard that we might be living inside a literal phantom that's trying to rip your atoms apart? So here's a wild thought for you. What if the energy pushing everything apart isn't just a constant force, but something that evolves, like it has its own main character energy that changes over time? Welcome to the bridge of the Intergalactic Express. This is your captain speaking. Please make sure your seats are in the upright position and don't touch the glowing buttons. We're still paying off the lease on this ship. Today we're diving into why the universe might be breaking its own rules, why dark energy is acting like a phantom, and whether we're all destined to end up in a giant cosmic blender. Let's get into it. Now let's look at the biggest scientific beef in the galaxy, DES versus DESI. Think of them as two rival detectives trying to solve the same cold case, but they can't quite agree on who the killer is. First, we have the Dark Energy Survey. Let's just call them DES. They're the seasoned veterans on our ship. Since 2013, they've been perched on a mountaintop in Chile using a massive 4-meter telescope to map out the stars. While some newer instruments are one-trick ponies, DES is the ultimate multitasker. They aren't just looking at one thing, they're auditing everything from exploding stars to how gravity literally warps the fabric of space. In January 2026, the DES team finally dropped their big results. Their main message, stay calm everyone, the old rules still apply. They're sticking with the standard model of the universe, which scientists call Flat Lambda CDM. This model is basically the vanilla flavor of spacetime. The universe is flat, dark matter is cold and slow, and the cosmological constant, represented by the Greek letter lambda, is just there. It's like a background noise that never changes. But here's the plot twist. Even though DES is backing the old-school rules, they admitted there's a catch. They haven't finished crunching the numbers to see if a newer, more chaotic model fits the data better. When they look at individual clues, they're seeing a weak preference for something that evolves over time. It's like saying, the engine isn't broken, but we're starting to see some very weird glitches in the code. We need more data, and the clock is ticking. So, things are looking pretty spicy for this thing called dynamical dark energy. But if the old school rules are out, what exactly are we dealing with? Enter phantom energy. This isn't some ghost story, although it's definitely scary enough to keep astrophysicists awake at night. The idea came from a physicist named Robert Caldwell back in the early 2000s. To understand it, we need to look at the equation of state. Don't worry, I won't make you do math. It's basically just a ratio between how much energy there is and how much pressure it puts on space. In the standard model, this number is -1. This means dark energy exerts a negative pressure that gently pushes space away. It's like a steady, predictable breeze. But phantom energy, it's defined as being less than -1. And here is the kicker. As the universe gets bigger, phantom energy actually gets stronger. It's like a car that accelerates the more it runs out of gas. It defies all common sense. According to the DESI results, for the first 2/3 of cosmic history, the universe was basically in phantom mode. If that had kept going, we'd be heading for a big rip, a literal cosmic shredder that would tear galaxies, stars, and even your own atoms apart. But something weird happened about 4.5 billion years ago. Phantom energy suddenly calmed down and transitioned into the weaker, ordinary dark energy we see today. Scientists call this moment the phantom crossing. Think of phantom energy as a pen balanced perfectly on its tip. It was unstable, wobbling around, and eventually it just had to topple over into a more stable state. But why? Was it a choice? A glitch? Or just the universe catching its breath? We honestly have no clue, but thank God it did, or we wouldn't be here to talk about it. If we stick to the old-school, standard model, the future of the universe is pretty predictable, but honestly, a bit depressing. It's what scientists call the Big Chill. Imagine the loneliest party in history.
Everything just keeps drifting farther and farther apart until the universe becomes so sparse and empty that there's no real sense of anything existing at all. It's not a bang, it's just a long, cold fade to black. But with this new, dynamical dark energy, the script is wide open. Since we don't have a perfect physical model for it yet, we have no idea what it'll do next. It's like a main character in a TV show who's prone to sudden mood swings. Maybe phantom energy makes a comeback and we get the big rip, where the expansion goes so fast it literally shreds the fabric of space. Or maybe dark energy just switches off. If that happens, gravity finally wins the tug of war, pulling everything back together into one massive, final, big crunch. It might even bounce. We can only speculate. It's scary, sure, but there's something reassuring about the fact that the future isn't set in stone. The universe still has some plot twists left in its pocket. Now, you might be asking, Captain, how do we even know all this? Did someone go out there with a giant tape measure? Well, sort of. It all started a century ago with a guy named Edwin Hubble. He discovered that the universe is expanding, and he came up with the Hubble-Lemaitre law. It's a simple rule. The farther away a galaxy is, the faster it's racing away from us. Think of it as the ultimate cosmic social distancing. Every megaparsec of space, that's about 3.26 million light-years, is expanding by a certain amount every second. When you add dark energy into that mix, it's like putting the expansion on steroids. And to map all this, we use the DESI instrument. This thing is a beast. It has 5,000 tiny robotic positioners that point optical fibers at thousands of galaxies at a time. So far, they've measured 13.1 million galaxies and over 1 million quasars. It's building the most detailed 3D map of the cosmos ever made, just so we can figure out if the floor we're standing on is about to vanish. So, where does that leave us, the passengers of this tiny blue rock? The uncertainty of the universe can feel overwhelming, but look at it this way. For billions of years, the cosmos has been balancing on a knife's edge, shifting from phantom mode to the stable era we live in now. We are the lucky ones who get to witness this brief moment of stability, but it also reminds us that we're all on the same team. Whether you're in New York, Kyiv, Tokyo, or a research station in Antarctica, we are all drifting through a vast, mysterious, dark ocean on the same spaceship Earth. Our future isn't written in the stars yet. We are the ones observing it, measuring it, and trying to understand it. To make sure our stories aren't erased and forgotten in the next few billion years, we need to keep pushing the boundaries of what we know today. Support science, stay curious, and maybe, just maybe, we'll find a way to stay on this ride a little longer. This was your captain. Mission accomplished. Now, someone please go check on the engines. I think I heard something rattle. See you in the next one.